day each and everyone. So today's video will present to you and explain about what is sequence and the two types of sequence. So first, what is the definition about sequence? Sequence is enumerated collections of objects in which repetitions are allowed in order matters. So what are the two types of sequence? We have the arithmetic sequence and we have geometric sequence. So what is arithmetic sequence? Arithmetic sequence is a pattern of numbers that increasing or decreasing at a constant amount. So let's have an example. We have 1, 4, 7, 10, and 13. We can say that this is arithmetic sequence because they are increasing at a constant amount and they have both common difference. For each arithmetic sequence, identify the term a sub 1 and the common difference of d and the next term in the sequence. To get their common difference, you must subtract the 4 and the 1, and the answer is 3. So the 3 now would be the common difference. A sub 1 is equal to 1. Now, a sub 2 is equal to 1 plus d, which is the 3. So the answer is 4. Now, let's check the a sub 3. A sub 3 is equal to 4 plus d, which is the 3, the common difference is equal to 7. Next is the a sub 4. A sub 4 is equal to 7, then added by the common difference, which is 3. So we have 10. Next is the a sub 5. A sub 5 is 10, then adding by the common difference, which is 3, and the answer is 13. And that would be the increasing of their common difference. So now, we get the formula of how to find the 10th term of the sequence 1, 4, 7, 10, and 13. So first, we have the formula of an or a next term is equal to 1 plus n minus 1 and the d, which is the common difference. So we get the 10th term. A sub 10 is equal to 1, which is the first a sub 1. Then next is the 10th term minus 1, and then close parenthesis, which is the 3, because that would be our common difference. So next is the a sub 10, then bring down the 1 plus 10 minus 1 equals 9. Then bring down the 3, which is the common difference. Next is the a sub 10 equals, bring down the 1, then 9 times 3, which is 27. So next is a sub 1 is equals to 27 plus 1, which is 28. So now the a sub 10 would be the 28. Summations of arithmetic sequence. The definition of summations of arithmetic sequence is the sum of all the terms of a sequences. So we have the formula. S sub n is equal to n, then a sub 1 plus a sub n divided by 2. So we have the a sub 1, back to our example, we have 1, 4, 7, 10, and 13 arithmetic sequences. So the a sub 1 would be the 1, then the a sub 10 would be the 28. Next is S sub n is the 10th term. So this is the a sub n or a sub 10 equals to the n, which is the 10 also. So a sub 1, which is 1 plus a sub n, which is the 28, divided by 2. Next is the s sub 10 equals to 10, then 1 plus 28 divided by 2. Next is the bring down the 10, a sub 10, then bring down the 10. 28 plus 1 would be the 29 divided by 2. So to multiply the 10 times 29 over 2, we must need to put the numerator of 10. So 10 times 29 over 2 we have to get the cash out of 10, we have 5. So, 5 times 29 is equal to 145. So now, the 145 would be our sub 10. This is the sum of the first 10 terms of the given sequences. The next topic that we will discuss is all about geometric sequence. So what is geometric sequence? Geometric sequence is a sequence of non-zero numbers where each term of the first is found by multiplying the previous one by a fixed zero numbers. That's called the common ratio. So we have the geometric formula. So we have a sub n is equal to a sub 1 times the ratio, then to the power of n minus 1. So to get that formula, we must need that a sub n. What is a sub n? A sub n must the sum of all the terms of given geometric sequences. That is the called nth term. Then next we have the a sub 1. The a sub 1 must be the first term of the sequence. Then we have the common ratio. The common ratio is the divided of the two terms of the sequence. Then last is we have the numbers of terms, which is the n. So let more deep conversations about the geometric sequence. So let's have an example. Find the seventh term and of the geometric sequence. So we have 3, 6, 12, and 24. So the a sub n is equal to a sub 1 times the ratio, which is the r, then to the power of n minus 1. So the a sub n must be the seventh term, equals to 3, which is the first, which is the a sub 1. Then times of 2, because that was our common ratio. Then again, raised to the power of 7, because that was our seventh term, and then minus 1. Next is a sub n is equal to 3 times 2 to the power of 6, because 7 minus 1 is equal to 6. Then a sub 7 is equal to 3, bring down the 3. Then 64, because 2 is multiplied to itself by 6 times. So, which is the 64. Next is the a sub 7 is equal to 192. Because 3 times 64 is equal to 92. And that would be the seventh term of the geometric sequence. Next is the summations of geometric sequence, which is that is the sum of all the terms of given geometric sequence. Let's have an example. We have 3, 6, 12, and 24. So we will find the sum of the 5 terms of the geometric sequence. So first we have the formula. The formula is Sn is equal to a sub 1 times 1 minus r, which is the ratio, to the power of n of term. Then over the 1 minus r. So let's have the fifth terms. So S to the power S sub 5 is equal to 3, which is the a sub 1 times 1 minus 2, which is the ratio, over 1 minus 2. So next, bring down is S sub 5, bring down the 3, which is our first a sub 1, times 1 minus 1 times 2 to the power of 5. So 2 is multiplying to itself by 5 times. So over 1 minus 2. Next is S5, bring down the 3, times 1 minus 32, because that was the exact answer of 2 times 2 times 2 times 2 times 2, which is the 32, over 1. Then S5 again, bring down the 3, minus 31, negative 31, then over negative 1. So let's have to answer that one. So we have S5 is equal to 31, 3 times negative 31, so we have negative 93 over negative 1. So to to calculate the negative over negative, we have positive 93. So, the exact sum of the 5 terms of the geometric sequence would be the 93. And that would be all. Thank you.